All right. Good morning, everyone. Welcome to the March California and Nevada Drought Early Warning System Drought and Climate Outlook Webinar. Thank you for those that have joined us previously and those that may be joining us for the first time. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NOAA's National Integrated Drought Information System, or commonly referred to as NIDIS. I cover the region of California, Nevada, and I'm affiliated with the Cooperative Institute for Research in Environmental Sciences at CU Boulder. This webinar is co-hosted with the California Nevada Adaptation Program and NOAA RESA team. We host these bi-monthly webinar series to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. Before we get started, please note this webinar is being recorded and the recording will be available on drought.gov and our YouTube channel later this week. We've got a great set of speakers this week covering current conditions and outlooks, as well as some new research on drought indicators. Before I get started, just a few slides about NIDIS, especially for those who haven't joined us before. Our mission is to improve the nation's capacity to proactively manage drought-related risk by providing those affected with drought with the best available information and resources to assess the potential for drought and better prepare for, mitigate, and respond to the effects of drought. We work to improve our understanding of how and why drought affects society, the economy, and the environment, and improve accessibility, dissemination, and use of early warning information. We fulfill our mandate by building a national drought early warning system, also known as a DEWS, through advancing regional DEWS, as shown on the map here, where we work with new and existing networks of federal, tribal, state, local, and academic partners to make climate and drought science accessible and useful for decision making. Information on drought conditions and impacts is also shared through the regional drought early warning system, such as webinars of this, as well as the U.S. drought portal known as drought.gov. Real quick, if you haven't been on our webinar series before, you will be able to see a recording of this after on YouTube and find information on drought.gov. I like to highlight the news and events section here on drought.gov, where you can find the latest news, upcoming webinars, past webinars such as this. At this QR code, you can also sign up for NIDIS emails, find regional drought status updates, and other information as well. So that news and events, as well as the other tabs, are useful for your information. Real quick, just a couple of highlights on some of those news and events that you may be interested in. On the left is one of our newest news articles talking about the new El Niño Southern Oscillation Index and how that is supporting drought early warning, as well as you can find links to our most recent snow drought update, which was from March 12th, so you'll get more up-to-date information today, and then a new one of these will be coming out post-April 1st as well. And then I also wanted to mention a webinar series in case you are interested in ecological drought. This is a continuing series. We started this in 2024 with different presentations on ecological drought. We are setting up another set of 3 different webinars. You can sign up for one, sign up for all of them. You can find that information at the QR code on the page or go to drought.gov and events, and you can find the first one on April 30th. Ecological drought considerations into restoration efforts and natural resource management. With that, just a few thoughts. So let's go through our presentations today. As I said, we're going to have an update on the Drought and Climate Update and Outlook. Dave Simeral, who's with the Western Regional Climate Center at the Desert Research Institute, will be providing the update. Then Michael Hittle from the National Weather Service California Nevada River Forecast Center will be providing the outlook. And finally, our third presentation will be on the new research on drought indicators and understanding regional and seasonal significance from Molly Wallison, who is with our NIDIS team and series. Before I move to the next speaker, I just want to quickly add, since this is a newer platform for us, if you haven't joined us before, where you'll be able to enter questions. You can enter questions at any time during the webinar. If you're on the web browser version, which is the version on the left, you can click this apps button, and inside Slido there, you'll be able to ask questions and send us questions. And if you're in the app version, it's similar as well. You can click the Slido button and send questions as well. So feel free to answer or to send in questions during any of the presentations. We'll answer a few in the middle, but most of them will be at the end. With that, we'll move on to the drought and climate update from Dave. Dave, are you there?
I'm here. Can you hear me?
Yes.
All right. Okay, I'm going to get started. As you can see on the first slide, I thought this was, I just took this photo flying from Reno down to Arizona in the past week. And I thought this was a fitting start And if you look at this, a picture of the White Mountains, which skirt the California-Nevada border on the left side, Fish Lake Valley. The right side is Owens Valley and the Southern Sierra off in the distance. But something that I took note of in the White Mountains, which go up to about 14,250 feet, is just the lack of snow cover overall, even at the highest elevations up at, above 12,000 feet. Okay, so let's get started. Next slide, please. Okay, so first we're going to talk about the current drought situation, and we'll take a look at the maps here. So if you could see the first two maps on the left, these are the current U.S. Drought Monitor maps for the past week, and the top shows California, and as you can see, there is no drought currently in California, although there is an area of D0 abnormally dry conditions that have been introduced over the past month in the northern part of the state due to short-term deficits, precip deficits, shallow snowpack over the last 30 to 60 days. Down below, that's the Nevada map, and as you can see, got about almost half of the state that's currently in D1 to D2 drought. As you can see in the darker colors, the more severe drought is in the northeastern part of the state, as well as in east central Nevada. And on the right-hand side, you can see those are the change maps. So that's what's changed within the past month in each of the respective states. And you can see on the top that introduction of D0 has just occurred recently in the past month, as well as further deterioration, that introduction of D1 over kind of the northeastern, north central part of the state, as well as some additional deterioration within the north central part of the state. So as far as impacts, we're not seeing much in the way of impacts in terms of what's being reported to the National Drought Mitigation Center. They have a monitoring observing system that logs impacts around the U.S. and currently we're not seeing any in the past 30 days. However, as you can see on here, we've had some deterioration in the past month. The only existing prior impacts that have been carrying over the past throughout the winter and prior to that would be existing impacts in terms of low reservoirs in northern Nevada in the Humboldt River Basin, as well as to the large reservoirs on the Colorado River with Meade and Powell. Next slide, please. Okay, next we're going to take a look at the temperature rankings, and these are from NOAA NCEI. These are the climatological rankings data through the end of February. Those update at the beginning of each month. So on the top right, we've got these are the regional climate rankings, and fortunately, the region that I have a box lined around that is the West Climate Region, which includes California and Nevada. And as you can see, that for the December through February period, the last 3 months, is the warmest on record out of the 131-year record. Breaking that down into climate divisions, so you can get a little more detail as to where that's happening. These are climate divisions. So on the left-hand side, obviously California, right side Nevada. On the California side, you can see two of the climate divisions in the southern portion of the state are the warmest on record for the past 3-month period. The rest of the state, second warmest on record. Moving over to Nevada, the entire state, all the climate divisions are warmest on record. In addition, looking back further in time, Nevada has been the warmest on record from time scales from the past 3 months all the way back to 36 months. So that's very significant. Looking at California, past 3 months to 12 months timescales, second warmest on record. So not quite as severe as what Nevada is experiencing. Next slide, please. Okay, so most of us are aware of the past week and the heat wave that we've been experiencing here. It's been national news, and I thought I would take a couple slides to take a look at that in a little more depth, because it was a very significant and it's actually ongoing heat event, and it started late last week. And if you look at the two maps on the left-hand side, that was the National High Forecast map on Friday. And as you can see on the boxed area, which includes California and Nevada, very high temperatures, unseasonably hot temperatures for this time of year, ranging into the near 110 in Southern California in the desert areas in the Mojave, and even as far north in Northern California and San Francisco, getting up to close to 90. So we're seeing 20 to 35 degree above normal temperatures. And those, we've got a little bit of a break today, and the heat's supposed to build again in the coming days. The map down below that, that's from Friday again. Those are the temperature departures. I just wanted to give you an idea what that looked like and how extreme those temperature departures were for this time of year. And I'll get more into that into the next slide, some of the actual numbers. On the right side, those are two maps that are showing. On the top is the average maximum temperature over the past week. And you can see the 90s and 100s in the Mojave Desert, as well as extending over into the Central Coast area of California, 80 degree, 70, 80 degree temperatures extending into far northern California. And below that are similar to the map to the left of that. These are the actual departures over the past week. And you can see we've got departures over 25 degrees above normal. Next slide, please. Oh, one more comment, sorry on that. The heat wave we're experiencing here is comparable to one that we experienced in April of 2021. We had a heat wave event that occurred late in the month, which triggered a rapid snowmelt across the western US. Okay, so this is digging in a little deeper into what we've been seeing in terms of records being broken. So the map on the right-hand side, this is a maximum temperature rankings map for last Friday. And each of the individual numbers you can see on there, those are actual observing stations across the West. And these are basically rankings for the day, for that particular day. So you can see all the ones on there. That means that that was a record high that was set for that day. So to me, what really stands out is not only the extreme nature of the departures that we're seeing in terms of the temperature anomalies, but also the spatial extent of how much of the West was affected and has been affected by this current heat event. So very significant. And I'll talk a little bit more about the impacts of such as we move forward. And looking at some of the departures, you can see on the left-hand side, I've noted some of them. 90 degrees in San Francisco on Friday, which is quite remarkable. 28 degrees above normal. LA got up to 96, and places in Nevada, same thing. I live here in Reno, Nevada, 85 degrees and a 25 degree departure from normal. If you look at the map in the bottom left-hand side, this is a map that shows daily records, either records that are tied or broken, as well as monthly records that are broken. And this was just a snapshot from Friday of temperatures, maximum temperatures at about 3 in the afternoon on Friday. And you can just see the spatial extent of how much that heat impacted the western U.S. as well as the central portion of the U.S. Next slide, please. So moving on to precipitation, I have a map on the right-hand side. This is of percent of normal precipitation from the beginning of the water year. So if you're not familiar with that, that's dating back to October 1st, and that's up until present. The cooler colors on the map represent either normal to above normal precipitation for that period, while the warmer colors represent below normal. And I've just kind of highlighted a few areas that stand out. You can see areas of central and northern California, as well as portions of Nevada that have experienced well above normal precipitation for the period. Some areas have kind of missed out throughout the water year, including that area up in northeastern Nevada, which we saw in the first slide, is the area with the D1 and D2 drought area. As well, we have a couple of pockets of dryness up in the northwestern corner of California, as well as kind of north of San Francisco, up in kind of Sonoma County, Napa County, that area, and some down in the southeastern deserts as well. So how this has progressed through the year, we've had early season near to above normal precip that occurred, during October, November, and into December, which with the warm temperatures that we saw on the slide a couple before that, we had a lot of it falling as rain rather than snow. So despite the fact, and I'll go into this more into the next slide, that we've had very poor snowpack conditions. If you look at the water year to date precipitation, in many areas in the two states, it's been near or well above normal. So if you shift over to the map that's on the bottom left, I thought I'd show you the water year to date precipitation from the NRCS SNOTEL sites. These are just the ones that are in the Tahoe Basin and on the east side, Eastern Sierra, Central Sierra area. And I just wanted to highlight those because you can see for the water year, those sites are at slightly below normal to above normal precipitation. So when I say precipitation, this includes rain and snow. Next slide, please. Okay, looking at the snowpack, you can see on the right-hand side, this is snow water equivalent for the date on, this is on the 21st. All the red, you can see these are sites that are below half of normal. This is widespread not only in California and Nevada, but across the western United States. California is currently statewide 36% of normal. The southern end of the range and the southern Sierra is doing the best at 56% of normal. Northern Sierra, very poor snow conditions, 16% of normal. Nevada, likewise, poor conditions, 32% of median, and it's in the second percentile, which is very poor in terms of the period of record where it stands. So exceptionally low snowpack currently, and we should be normally at about peak conditions in terms of snow water equivalent at this time of year. Next slide, please. Next, I wanted to point out some of these very low sites. So this map on the right is, again, the current SNOTEL map through the 21st. And this is one that's showing the record or near record low sites. So the ones in red dots are SNOTEL stations that are at the lowest on record for the date. And you can see how widespread that is across both states. And then the ones that are in orange are second lowest. So, and the other ones, many of those that have nothing in them are, some of those have no snow on the ground at this point. If you take a look on the right, I have the plots for individual stations, and basically this is tracking the snowpack from the beginning of the water year. So you can see on the x-axis is the date, and the black line is the amount of snow for the current year in each of these respective stations. And I've highlighted it where we currently are right now. In that red area on the bottom of that plot, that is the 10th percentile. So that's the lowest 10th percentile, the lowest snowpack conditions in the period of record. So you can see that many of those are somewhere in that bottom 10th percentile, and some of them are basically breaking the record. You can also see, like in a couple of these at Lee Canyon and Levitt Meadows, where the black line is touching, that means there's basically no snow on the ground. So many of these sites have already melted out. Another thing that's notable is the green area. That's the median snow depth over the period of record, and there's a little green X in there, and that's the date in which, during the period of record, the snow water equivalent is at its peak value. So you can see where we are currently compared to those peak values. So what this is showing is we're getting a very early melt out of the snowpack. So it's going to probably end up, weeks to maybe a month early plus compared to the period of record. Next slide, please. And lastly, I wanted to just talk a little bit about the water resource end of things. So looking at reservoirs and stream flows. The next presenter is going to get into more detail about some of these topics. But first, I want to talk about reservoirs. The top one is a map. This is a teacup plot, and I wanted to highlight two of the major reservoirs that are impactful to California and Nevada, obviously Lake Powell and Lake Mead. Both of those are still, and this is a long-term situation, very poor condition. We have very poor conditions in the upper Colorado River Basin, below half of normal in terms of the snowpack. So we're going to expect to see significantly reduced inflow into those reservoirs, which is likely to create even a more critical situation, especially at Lake Powell moving into the fall months. But those two reservoirs are in really poor shape. Mead's at 34% full, and Powell is at 24% full. Right below that, moving over to California's reservoir systems, we have a different picture there. Those are the major reservoirs within the state, and I've highlighted the two largest ones in the state, Shasta and Oroville, and both of those reservoirs are well above normal. So fortunately, we're in a pretty good condition in terms of the reservoir levels moving into the summer months, and despite the shallow snowpack and reduced runoff that we're expected to see coming out of the Sierras. Bottom left-hand side, I just wanted to note those two reservoirs in northern Nevada on the Humboldt River system, which were already in poor shape moving into this season, and those are expected to deteriorate more with the poor snowpack conditions in the upper part of that basin. And right-hand side are the current stream flows, and I put a box around the two areas where we've basically been seeing below normal precipitation over the past several months in those areas. And you can see the one in the upper right is on the Humboldt River system, and you can see all the low stream flows there, as well as ones up in Northern California as well. And the final slide, please. So just some key takeaways from this record warmth across both California and Nevada. Snowpack is well below normal, despite the region experiencing near to above normal precipitation for the water year. Conditions are consistent with a warm snow drought. Extreme March heat is accelerating the snowpack meltout. and an elevated risk of emerging drought heading into the summer months, particularly in Northern California and Nevada. And you can see the three maps just to the right of that. On the top is the seasonal temperature outlook, and that's April through June. And you can see this trend we've experienced throughout the year is going to continue with above normal temperatures, and there's a high probability of that across the western United States. Looking at precipitation outlook, northern portion of California and Nevada, low to kind of moderate probability of below normal precipitation for the rest of the spring and early summer months. And then the seasonal outlook, drought outlook, which shows drought development in northern Nevada and northern California, as well as drought persisting in northeastern Nevada. All right, thank you very much.
Thanks, Dave. With that, we'll pass down to dig a little deeper into the outlook with Michael Hittle from the National Weather Service California Nevada River Forecast Center. Mike, do you want to bring up your slides? Oops.
Okay, everybody seeing that all right?
Yes, you're good to go.
All right. I'm also going to do a little bit of a recap from our end of what's gotten to this point in the year before I get into the outlook. We did enter 2026 with some relatively good conditions. On the left is the December 25th issuance of the drought monitor, and you just see the small areas of abnormally dry near San Diego, far northern interior California, and a little bit more widespread in Nevada. And then on the right, that is the percent of average precipitation just for October through December 2025. Extremely wet fall for the transverse ranges and up into the northern Mojave, with some very dry conditions along the far north coast, the upper Klamath River Basin, the San Diego Mountains, and much of northern Nevada. Bringing it down a little further, that period ranks in the top third of wettest years for most of the region. The numerical values show how this past October to December ranks as far as the wettest in the last 131 years. Regions displayed here do simplify things a little bit. There's some drier areas in there. We're calling the areas near San Diego on the last slide. But still, with the January 8th issuance of the drought monitor, we see dry conditions trimmed back significantly in Nevada and completely removed from California. But even at that time, we're starting to get pretty concerned about the state of the snowpack. What you're seeing is the basins in which the California Nevada River Forecast Center models water equivalent of accumulated snow. And with a few exceptions along the highest elevations in the far southern Sierra and isolated places in Northern California, we were well below the year-to-date average on January 1st. And that trend continued into February. Looking at things as compared to the average April 1st date of the peak snow water equivalent. The left is February 16th, and we're looking at the snow pillow values that day as compared to the April 1st average for 1991 to 2020. All of Northern California, Northern Nevada, the Spring Mountains outside Vegas below 30% of April 1 average, while the central parts of both states were 30 to 40%, and the Southern Sierra just shy of 50. And then on the right, that's February 24th, after the big mid-February storm. We see some dramatic increases to where the Southern Sierra and Spring Mountains are now 70 to 80% of April 1st average. Rest of both states still well below averages, but still increases of 10 to 30%. And unfortunately, that's about as good as it got. You're seeing the daily progression of snow water equivalent as a percentage of regional April 1st averages. There's a steady increase during the storm period until about February 24th, 25th. And when that very warm atmospheric river arrived, you see a much more pronounced effect in the north. That's just where it landed. And then beginning in early March, we start to see the bigger losses across the region as the extremely unseasonal temperatures set in. In a span of just over a month, we saw a pretty dire snow drought improve significantly and then fall back to much worse than where we started. It means that instead of the snow water equivalent peak around April 1st, it's likely passed in every region already. It's really not that unusual to have peak SWE arrive before April 1st. For the 91 to 2020 period, I calculated the average peak date in California at about March 20th. For Nevada, March 25th. This year, assuming no further major storms arrive, the statewide average in both states peaked in late February, and that is unusual. Nevada's statewide average peaked on February 25th, tied for the earliest date since at least 1991. California was 1 day earlier, and that is the third earliest in the same time frame. And I do want to call out those two earlier years in California. One was 2015. That was the year with the lowest statewide average snow water equivalent ever recorded. And the other was 2022, and we had a pretty dry February through April period, but there was nothing similar as far as the speed of melt, the high temperatures, and the runoff that we've got this year. A couple of causes for that. On the left, we're seeing the elevation where freezing conditions were observed on February 24th to 25th, anywhere from about 8,000 or 9,000 feet in the north to more than 16,000 feet in the south. And snow may fall as much as 1,000 feet lower than the freezing level, but in this case, that would still be well above ground level for most of the region. That red star is Oroville Dam, which is about 900 feet elevation. On February 24th there, falling snow began melting at 10,000 feet, which is higher than almost all of the land area in the basin. High temperature at Oroville that day was just below 60 degrees. It was a very warm storm that caused a lot of the low elevation snow to melt. And then higher elevations where we still had rain falling, the snow was able to absorb a lot of that rain. In the center are rain-caused runnels at Castle Creek, which is 7,400 feet on February 26th. On the right is Lions Creek, 6,700 feet on March 2nd. That circled area shows about 8 inches of standing water on top of the snow, and where that surveyor is standing, the snow was measured at about 3.5 feet deep. Castle Creek, it's closer to 5.5 feet. The bigger effect in the melt begins in early March. The left image plots the trend in our model's forecast of seasonal runoff. It's looking at both accumulated snow and the forecast over the next 10 days. Where the arrow is, the forecast has begun to show no further storms in the near future. Then you see it begin to make a very steady drop as the high temperatures start to show up in the forecast. In the middle, that's the forecast departure from the normal high for March 19th. Most of Nevada is forecast more than 30 degrees above normal, and almost the entire area 10 degrees above normal. On the right, from the Western Regional Climate Center, we see that the average daily temperatures, daily median temperature average through March 1st through the 19th was at least 6 degrees Fahrenheit above normal for most of California. And this has had a really dramatic impact on our seasonal flows. Beginning with the image on the left, we're looking at the date of CNRFC's forecast peak snowmelt flow for the major river basins contributing to water supply. Those dates are generally within 2 to 3 days of today. In the middle, you're seeing the average peak date for that 1991 to 2020 period, generally late April to mid-May. And then finally on the right, this year's departure in number of days. For the Northern California basins, which do tend to peak earlier because of the lower elevation, we're still more than a month ahead of schedule. For the Central and Southern Sierra, we're approaching 2 months, and in the Walker Basin, more than 2 months. Many locations, we expect the snowpack to fall below 2015 levels within the next week or so. And that's produced some interesting results. On the left, this kind of goes into what Dave was saying. We've had some pretty high precipitation so far this year, primarily at rain. And that is looking at the average percent of year-to-date stream flow through last Friday for most of our major forecast basins. You see the vast majority are either well above average for this time of year, and that's driven by two things: a wet fall and the had an outsized influence in Southern California, down here around Point Conception. And for the snow basins, including the valley portions of the Sacramento and San Joaquin rivers, the primary effect is the early snowmelt. A lot of the flow captured in this would normally occur between April and June, so as we go deeper into spring and summer, these percentages will decline. Just a visual example on the right, that is a rapid on the South Fork American River just a couple weeks ago, and it's flowing at nearly double what it averages for that date over the last 30 years. And what's especially concerning about that is that less than 1/10 of an inch of precipitation fell over that basin since March 1st. That average is, the average for the month is 4 to 5 inches across the region. That's a pretty consistent story for nearly all of the CNRFC domain. March to date sits at roughly 0% of the monthly average precipitation, and that's what you're seeing on the left. As of our afternoon forecast cycle on Friday, there was no relief through the rest of this week. The small amounts that you're seeing, maximums of about 1 inch, are in some of our wettest areas. The monthly average along that portion of the north coast is 8 to 9 inches. Going further out, this is the Climate Prediction Center's seasonal outlooks issued last Friday. Similar to what we've seen so far in March, above normal temperatures and below normal precipitation. In both of these cases, the color gradient indicates the likelihood of above or below normal, not how far above or below normal we're expected to be. That said, it's important to remember that beginning in April, the monthly average precipitation begins to drop sharply. The total statewide precipitation for the months of April through July in California averages about 3 inches. And then we're looking at a couple of images from NASA's EarthView. On the left, April 4th of 2025. On the right, March 19th, this last Friday. Huge decrease in snow-covered area for those two dates. I believe I've actually got the wrong image on the left. But we see northern Nevada, northern California almost completely snow-free, and it's confirmed by the snow pillow values. On Friday, 61 of the 173 pillows which reported a daily value showed no remaining snow. And the vast majority of those with anything left are in the central and southern Sierra. About 60% of the stations in all of Nevada and in the Klamath Basin in northern California are at 0. With the continued high temperatures, that number is going to steadily increase. As we'll see on the next slide, most of Nevada is already downgraded to at least abnormally dry on the drought monitor, with similar conditions in much of northern California. And we can expect that to deteriorate further as the last of the snow melts out and the soils begin to dry. Just quick recap. We had a very wet fall, which helped us to remove drought status in most of the two states. Winter lacked snow to begin with. It stayed that way through the entire winter, peaking in late February. It's been a very hot month in March. Record temperatures, melting snow produced peak river flows extremely early, and the outlook is not good. Below average precipitation and above average temperatures expected. We can expect a drought to return or intensify through most of the region. And that is all I have.
Thanks, Mike. With that, there's a couple quick questions I'm going to cover for Mike and Dave right before. I think most of these are for you, Mike, though. This one came in before the Outlook sort of section you had in, so maybe you want to elaborate a little bit. They're asking, it is unlikely that any April precipitation will significantly relieve the situation, correct?
Yeah, that's correct. April is one of the wetter months for that time of year, but it doesn't compare to anything between about October and March.
And then the second quick question is, you said we've never experienced this rate of melt before. Have April or May melts compared to this March one, or is this unprecedented for any time of year?
Yeah, we have seen April and May melts that are on the same order. It's just the timing this year that's really the most significant part. A melt of that rate is a pretty big deal at any time, but in March it's unheard of.
Great. Not always the best news, but gotta deliver the news. All right. With that, we're going to move on to our third presentation on some new research on drought indicators. With that, before I do that, I just want to remind folks that they're on. If you haven't gotten your questions in yet, we'll see how many we can do at the end, or we'll circle back with you after the webinar. Click on apps if you're in the browser to send questions, or on Slido if you're in the app to send questions in. With that, Molly, I'll go ahead and pass it over to you.
Okay, great. And I believe there we are. Okay, perfect. Hello, everyone. My name is Molly Wolozin. I am with Amanda at Ceres and NIDIS as one of the regional drought information coordinators. And I'm excited to talk with you today about some research that NIDIS partnered on with NASA, and which led to the development of a new online resource that we'll be sharing today. Next slide. Monitoring drought is complex, and it often involves tracking multiple indicators of drought, as we've seen in this presentation. Variables like precipitation, evapotranspiration, soil moisture, and other indicators as well. But the importance of any given indicator is really going to depend on where you are, the time of year, and other risk factors for a certain location. So helping to improve our understanding of relevant drought indicators for specific areas and seasons can help us with more effective drought planning, communications, and decision-making. Next slide. So to begin to tackle this question on what are the most relevant drought indicators by region and season, NIDA's partnered with NASA a few years ago to help us help quantify the relative importance or drought explainability of specific indicators with respect to the U.S. Drought Monitor. So in this study, researchers looked at 113 indicators of drought, and that included both observed data as well as modeled and in situ data. I'm not going to get too much into the weeds of exactly how this study was done, and I'm really going to focus on the results. But this research used something called mutual information to compare the 113 indicators to the U.S. Drought Monitor from the years of 2006 to 2019. And they produced what's called fractional information for each of these indicators with respect to the U.S. Drought Monitor. So the results of this study shows us what type of or how much drought explainability each of these indicators can give us with respect to the U.S. Drought Monitor. If you do want to know more of the methodology, I believe that Kelsey just put the link to the study in the chat box, and I encourage you to check out the publication. Next slide. So, oops, I think maybe go back one. There we are. So this is just a quick look at the indicators that were included in this study. They're broken down by observation based on the left, model based in the middle, and remotely sensed on the right. And you can see that it's a wide range of indicators, including precipitation variables, Palmer drought indices, soil moisture, evapotranspiration, runoff, stream flow, and other variables as well. Next slide. Before we get into the results of this research for the Western US, I did want to talk about some of the research caveats for this study. There's a lot of text on this slide, but I'm just going to kind of step through it one by one. So first caveat is that this study does use the U.S. Drought Monitor as a training target, using the time period of 2006 to 2019. So if you were to adjust to the target or the time range, you likely would get different results for the different indicators. So not all of the indicators that are used by the U.S. Drought Monitor authors were included in this study, as the indicators have changed over time and new data sets have become available. I wanted to emphasize that this study cannot tell us what data sets were used by the U.S. Drought Monitor authors, but it can tell us which data sets have correlation to the U.S. Drought Monitor for that 15-year period. Next slide. Or next, yeah, click the button, there we go. I also wanted to note that, we saw that big list of indicators and timescales that were used in the study, but we wanted to recognize that there were some indicators that are used by state and local governments to monitor drought that were not included. For instance, reservoir levels were not included in this study. Also, there were a limited number of snowfall data sets, the snow water equivalent, runoff, and stream flow compared relatively to other data sets like precipitation. Also, the timescales included in this study go from 1 month up to 72 months. So for flash drought, shorter timescales on the order of 1 to 3 weeks might also be more relevant, and those are not going to show up in this study. Click one more time, please. And then finally, what you will see as we get into the results, especially for the Western US, this analysis was conducted at a fairly large regional scale. So of course, geographies and climates may vary across these large regions, which means that there might be some nuances to the results that you see. So the study did analyze the indicators, as I said, through 2019, and looking at these individual indicators, individual drought events or the current drought there might be other indicators that are relevant for those droughts as well, as each drought can be driven by different factors. Okay, next slide. So the overarching key takeaways from this research are that the results of this research can show us which drought indicators are most representative of the U.S. Drought Monitor's depiction for a given region and season. It also found that no individual indicator can define drought on its own, as I'm sure all of you probably know, and that there are seasonal differences. So we do get higher drought explainability and fractional information values when we combine multiple indicators together. Another takeaway is that the top 15 indicators of fractional information can capture roughly 55 to 75% of explainability for the U.S. Drought Monitor. So that shows us, if we are able to just take those top 15 indicators, that we can explain most of what we see on the U.S. Drought Monitor, as opposed to having to look at all 113. Also, the study looked at just model-based indicators, and it also showed similar explainability for the U.S. Drought Monitor. So that shows promise for drought prediction and forecasting, as well as the remotely sensed indicators show value for drought monitoring where areas are scarce with data. So those are the overarching key takeaways. And now if you go to the next slide, we're going to get into some of the key takeaways for the Western U.S. So this slide shows again that the Western U.S. is a large region. So I do want you to remember that we realize that there might be nuances and differences depending on where you're looking in the region. So for this slide is showing us all of the seasons combined. So for the entire year, these are the indicators that come out on top, and that includes our evaporation-based indicators, the Standardized Precipitation Evapotranspiration Index, or SPEI, and precipitation-based indicators. And both of those, we see timescales anywhere from 6 months up to 24 months that are relevant for the Western U.S. We also have groundwater and soil moisture as a top indicator that emerges in the Western U.S. across all seasons, as well as the Palmer indices, both the modified and the hydrological. Next slide. So getting into the seasonal data and the differences that we see across the seasons. So some of the key takeaways there include that SPEI, again, the Standardized Precipitation Evapotranspiration Index, actually dominated as a top indicator across all seasons. And for those that aren't familiar with SPEI, it is an indicator that takes into consideration not just precipitation, but also temperature. So this shows the importance of temperature as a driver for drought in the Western U.S. for drought. Soil moisture has seasonal importance, so it emerges as a top indicator in the summer and the spring, but not in the winter or fall. And looking at the different timescales that are most relevant, fall and winter favor longer timescales. So we typically saw timescales of 24 to 36 months in the fall and winter, and shorter timescales emerge in the spring and summer. And then generally, I will say, compared to all of the other regions across all seasons, the Western U.S. favored longer timescales on the order of 9 months or longer compared to other portions of the U.S., which makes sense since we do typically see drought persist longer in the Western U.S. as opposed to the eastern half. Next slide. So now we're just going to take a quick look at each of the seasons, starting with summer, which is considered from June through August, and SPEI and the precipitation-based indicators, SPI and precipitation, emerge as top indicators ranging from 6 months up to 24 months. So again, for the Western U.S. on the shorter time scales relative to other seasons, and also soil moisture, including the 1 meter and total column soil moisture, and then groundwater and the Palmer indices are top indicators in the summer. Next slide. So moving into the fall, as I mentioned before, we do see that our soil moisture has most relevance not in the fall and winter, but in the summer and spring. So that's why we don't see it emerge here. Again, SPEI, SPI, and precipitation, we do see some similarities for the other seasons, but the time scales anywhere from 6 months up to 36 months for SPI. And then for the precipitation-based indicators, again, ranging from around 9 months up to 36 months. Next slide. For the winter, it's where we start to see some of those longer time scales. So you can see that for both SPEI and our precipitation-based indicators, the relevant time scales go all the way up to 2 years or 48 months. And we also see our Palmer Hydrological Drought Index, the longer term hydro drought index emerge, as well as groundwater. Next slide. And finally, in spring, we do see soil moisture and those shorter time scales emerge as most relevant indicators in the spring season. And next slide. Next slide, please. So for the last few slides, I wanted to just discuss the process that we took to create an online resource that conveys this research and information. And I believe Kelsey went ahead and put the link to the online resource in the chat. So as I mentioned, this research was published in a journal, and we wanted to take the results of that publication and translate it into something that was more user-friendly and easier for people to access in order to incorporate it into their decision-making. So this timeline shows that back early last year in 2025, we started with having some listening sessions with the drought monitoring community to share the results of the research and to start to understand how they could make this information actionable for their work. Last year, we also engaged with the National Weather Service to help them build support for their local drought monitoring capabilities. And then we spent some time developing a prototype web page based on what we heard. And then finally, earlier this year, we did user testing based on that prototype web page and just launched it recently last week. So next slide. So you'll see on the website that you don't see this graph on there. So this is the original results graph that you would see in the publication if you did open that up. So this is just showing what it looked like. And then if you click Amanda, you'll see that what it looks like on the drought.gov version for the web page. It shows a much more user-friendly information grouped so that you can easily see which indicators come out on top. And if you go to the next slide, I wanted to also show you that if you click on the Explore the Data on the web page, you'll go to an interactive table where you'll get even more information about the indicator and the data sets that were used in the study. And one other thing that we provide is access to additional data sets. So where you can find SPEI or PHDI if you're interested in incorporating that into your monitoring or planning. So we did want to make sure that we could send people to find the right information for their local area. Next slide. And this is my last slide, but I did want to recognize that we are continuing to explore ways to produce this information at a finer scale. So for instance, the state scale, especially if you look back at the region, obviously the Western US is a very large region. So we do want to continue to explore at a smaller scale and then also incorporating other data sets in future studies like reservoir levels. So if you have any feedback on approaches or what would be most useful for you and your decision making, what you're not getting from this current resource, I would love to hear from you. So my email is on the screen. If you're not subscribed to the NIDIS newsletters, you can scan the QR code or Kelsey, maybe if you could put the link in the chat box to sign up for our newsletters to stay in the loop. We will officially be sending out notice for this new online resource in the next few weeks. But that is all I have, and I'm happy to take questions if we have time.
Thank you, Molly. As Molly mentioned, you can sign up for all these things. We also probably will be sending some information out with the post-webinar email as well, so you can dig in even deeper into this research and how it helps you. We would love to hear about it and how you may be thinking of using it or are able to use it. With that brings us to more questions and answers. So if you have any questions, please keep entering them in the box. Thank you. Before I read the couple more that have come in and give you some time to enter some more, I do want to say thank you all for joining us today and to all our great speakers, Dave, Mike, and Molly. We hope everyone found this webinar informative. I'll mention again that the recording of this webinar will be available on our YouTube channel later this week, and we will also be sending out via email if you registered for the webinar. I'll also note that post April 1st, we will be sending out a snow drought update. So if you sign up for the California Nevada listservs and that QR code, you will get our next snow drought update, as well as a California Nevada specific update we're going to be doing in the middle of the month. And our next webinar on this series is scheduled for Monday, June 8th. Hopefully there we're going to talk more about the update to the conditions, as well as potentially look out into the fire season and what may be coming up ahead. With that, I'll pass over to a couple of questions for Mike and Dave. The first one I will mention is actually related to that fire season, which maybe we'll have more information later on. But if you'd like to say anything, the question is it expected that a wet fall and the early melt will produce a higher amount of dry fuel during the fire season? Or is the amount of fuel, quote, baked in, quote, by rainfall with snowmelt not significantly affecting the conditions?
It does.
I can give that from our perspective. Really, it's more late spring precipitation that we would worry about for low elevation fuels. Fall time, it's not during the growing season. We don't tend to worry about that quite as much.
Great. And the other question we currently have in here is there a chance for a rapid onset of drought across Nevada and California later this summer or fall? How well can the reservoirs provide water resources across the Southwest region without the benefits of the snowpack?
As far as the rapid onset drought, I think there's always a chance of that, especially when we're seeing a forecast for above average precipitation, or excuse me, temperatures. But the reservoirs, it does get a little bit more challenging for them to supply water. Fortunately, in California, we were above average for the last couple of years. The reservoirs are in good shape, but it's just going to be a matter of water supply as the year goes on.
Great. Someone did ask to know who was speaking which. I will mention that was Mike Hittle who answered the last two questions for the National Weather Service California Nevada River Forecast Center. And I was going to call on Dave. Do you have anything to add about the onset, this potential for developing drought across the region for later this year? Do you have any feedback or information you want to add on there?
Yeah, I mean, I'm in agreement with what the outlooks are showing from CPC, that the areas that are currently in drought in the northern portion of Nevada, as well as we could see some more development and intensification of drought in Northern California. I would expect drought to become more severe in the case that especially in eastern and southern Nevada, northeastern part of the state as well, if monsoon season doesn't pan out well in those areas, and we have the above normal temperatures which are expected, I could see further intensification in those current areas that are in D1 and D2 right now.
Great, thanks, Dave. And so that was Dave Simeral at the Western Regional Climate Center. With that, I don't quite see any more questions, so maybe I'll wrap up here a little bit early. I would say thank you all again for joining us, and thank you to all the great speakers. If you do think of a question after this, feel free to reach out to me. My email is there on the slide, and you can find us on social media, YouTube, and our newsletters. Feel free to reach out if you have any more. There will be a brief survey that will pop up at the end when I close the webinar. Please feel free to fill that out and let us know what kind of information you received today. Was it helpful? Was it not helpful? And make suggestions for webinars going forward. So with that, I'll go ahead and wrap up and say thank you all for joining us, and hope you can join us next time in June.